I'm your host, Neil deGrasse Tyson, your personal astrophysicist, and today is yet another edition of Cosmic Queries. And I think this one is titled Galactic Gumbo. Is that right? Oh, co-host Chuck Nice.
Yes. Yes, it is. Galactic Gumbo.
I love that.
Gotta love that. Guarantee. They don't say Macon. Put it in there. And then I put in there the cayenne pepper. Cayenne pepper, that little dark matter. Little dark matter.
Little dark matter.
Little dark matter, little cayenne pepper. A little
black hole.
Little sprinkle black hole. And then I put in just a little bit of quasar. A little bit of quasar. Galactic Gumbo.
So if you were white and weighed 300 pounds more and were dead, you'd be a split.
I'd be spitting image of Paul Perdome. Right? Spitting image of Paul Perdome. Guarantee.
Chuck, great to have you. Love you on Cosmic Queries.
Of course.
So let's do this Galactic
Gumbo. Yeah, and of course, we always glean our queries from all across the internet, no matter where we are found and in what incarnation.
Nice.
And we always start with a Patreon patron because they support us financially, and very much like your elected officials, we too can be bought.
Is that right? So just to clarify. So we experiment on this show.
Yes.
In ways that would not otherwise be possible from just pure ad revenue.
Yeah.
Because there are things that would be risky. There are ideas we have that sponsors don't believe that it'll work.
Right.
We also do a few humanitarian things, and so that sort of front money that we get from the Patreon folks,
and we have a new outlet called Star Talk All Access for those of you out. So you can find that at StarTalkAllAccess.com, which is another revenue stream, and all these things help us grow the Star Talk universe.
Trying to bring the universe down to Earth.
There you go, baby.
Right.
So our Patreon patron is Elaine Griffith, who says that
we know where she's from.
She's from Oakland, California. She says, "Hi, Neil. This is Kendra from
Oakland." That's where Batman is from. Apparently.
What? Oh,
Superman versus Batman. Like Gotham City and what's the other one?
Metropolis
are across the bay from one another.
Oh, okay.
Yeah,
so it's Oakland and San Fran. Right. So Wayne, it makes sense because Wayne Industries, of course, like huge company, maybe a tech company.
Maybe a tech company, yeah. So it was just thought I'd tell you that.
Hey, that's very cool. So Kendra from Cali, as in Oakland, California, Elaine Griffith is my nom de plume. And then here's what she wants to know from you, Neil.
Okay.
Why didn't all the matter and antimatter created by the Big Bang cancel each other out, leaving nothing but energy?
Ooh.
Wow.
Ooh.
Look at that.
Ooh. Yeah, we take a lot for granted just living in this universe.
Right.
But it turns out that for every bit of matter in this universe, okay, there are, when all the matter was created, it left over photons.
Right.
Okay, so let me say that a different way. At the beginning of the universe, there was this hot cauldron of matter and energy moving back and forth between one another, according to E equals mc squared. E for
energy, M for mass.
Yeah, mass. Okay, so
constant.
That equation allows you, under the right conditions, to freely transform one into the other.
Nice.
So, just to tell you how this works, if you take energy and convert it into matter, you don't just get regular matter, you get equal amounts of matter and antimatter.
Right. Unlike your data plan with your phone carrier, your minutes in your data plan do not transfer back and forth equally.
That was as an obscure reference to the universe as I have ever heard.
Right. Can you hear me now, universe? Can you hear me now? All right. I'm going to stop. Go ahead.
So the way that equation works, you take a pulse of energy, convert it into matter, you get antimatter and matter in equal amounts, equal and identical opposite amounts. Then the matter and antimatter hang out for brief moments of time, and they recombine and make pure energy again. So this back and forth requires equal amounts of matter and antimatter. So as the universe cools and the energy isn't high enough to make particles out of it, we should be left with an entire universe of just energy.
Right.
No matter at all.
Right.
Okay? Because once the energy of the light, the photons, the pulses of energy drops below the energy necessary to make the lightest particle, there's no more particles to make. You just a low energy photon.
Right.
That's all you got.
That's it.
You can never aspire to become anything other than a photon.
Oh, I feel so bad.
Or other form of energy. You can never go become matter.
It's a caste system at this point. What a shame.
I didn't know you get all emotional about
No,
this.
I could have been somebody. I could have been somebody.
So here's what happened. In the very early universe, there was an asymmetry in the matter and energy. For every 100,000 particles of antimatter, did I say 100,000? I don't mean that. Sorry. For every 100 million, 10 to the 8th, every 100 million particles of antimatter, 100 million and one particles of matter were made.
Oh, uh-oh.
Symmetry in the early universe was broken by that little bit.
Just that tiny...
And you wouldn't even notice that little extra one until, like in a dance-off, your dance partners start peeling off.
Right.
You take off this pair.
Right.
Everybody thinks they got a pair.
Right.
And you just keep doing this.
Right. Until you're left with one dude just breakdancing in the middle of the party.
Nobody.
Like, whoa, where'd that guy come from?
Right? With nobody to mate with.
Right.
Okay? And that one is left. And so our universe is made of matter and not antimatter and not pure energy because of that one asymmetry. And we know it happened. We have a very good idea of when it happened in the early universe. We don't know why.
Oh.
Yeah.
Nice.
Yeah, it's just one of the mysteries of the universe.
Mystery of the universe.
I hate to sound cheap about this, but I recorded a video series for the Great Courses Company.
Called The Inexplicable Universe?
The Inexplicable Universe.
You know how I know that?
Wow.
Because I have it at home.
Oh.
Yes.
Very nice, Chuck.
Yeah.
And I didn't even give you that copy.
You did not give it to me.
You bought that thing.
That's right, I did.
Oh, my gosh. Yeah. Well, thank you.
Yeah. Well, that's how I do my homework. Because it beats reading.
Watching the videos.
I'm like, let me just get Neil and
you don't want to sound like a complete idiot.
Right, exactly. That's how I do my homework, man. I could, but go ahead.
Thanks for telling me that. So in the Inexplicable Universe, one of the topics is this great asymmetry between matter and antimatter in the universe.
Right.
And so I tell you how we come to learn that that's the case, but I don't tell you why that's the case because it's inexplicable.
Right, we don't know, and hence the title, The Inexplicable Universe,
exactly.
Right? As opposed to the next sequel, which will be the Totally Explainable Universe. Yes,
but that's what all videos are.
Exactly. That's every single video.
That's what wiki pages are for.
We call that Nova.
Exactly.
Yeah. No, seriously, I'm not even joking. All right, well, that was awesome. Hey, Elaine, what a way to kick off the show because that's really good stuff. Hey, let's go to Gregory from Bastrop, Texas.
Bastrop, yeah.
Bastrop, Texas.
Yeah, it's in West Texas.
Bastrop, West Texas.
It's in West Texas. Yeah.
Never heard of it.
Yeah.
Bastrop.
I think it's in West Texas.
Okay.
Yeah.
I mean, yeah.
I've been to that town.
Really?
Yeah, I've been there. Yeah.
Bastrop?
Bastrop, yeah.
Okay. All right. Sounds
not a big town.
Well, look, hey, listen, it's a destination, I suppose, for somebody.
For somebody.
I'm not going to hate on Bastrop. I don't know anything about it, right? So, hey, Neil, it's Greg.
It might be Central Texas.
That might be Central?
Yeah.
Okay. Hey, Neil, it's Greg from Bastrop, Texas. I've been thinking about this for a while, and it's actually a part of a book that I'm writing.
Nice.
Okay. So, when a glass breaks because its sound hits a specific frequency. Okay, so it's that Ella Fitzgerald old-time commercial.
How old are you, dude?
Old enough to remember that. I don't know who the who the product was, but I just remember they would put a speaker next to a glass and it'd be like, we're going to see if Ella Fitzgerald can break this glass. And the only reason I remember is because Ella Fitzgerald was a friend of my grandmother's.
Oh, okay. All right.
She'd be like, ah, and then the glass would start to vibrate and shatter.
So what happens is you can break glass with a frequency of sound that goes through it, or you can just smash the glass. Okay, just to be clear, that would not be the only way to break a glass. Right. But the way the question was posed is, this is how you break glass.
Right.
No, you can just step on it.
Right,
okay?
you can just break it. Right.
Break it. So what happened in any Jewish wedding? They
Right,
break
exactly. Just step on it and mazel, and now your life is ruined.
Right.
So, but he says this: what if the strings in string theory making up the universe are vibrating at a specific frequency, and that frequency is what determines the laws of physics in the universe? Maybe each universe making up the multiverse has its own unique frequency, and that could be the key to traveling to another universe. He has made many assumptions in this.
It's good. I love it. I like it. It's good.
Really cool.
Now, let me first preface this by saying I don't claim string theory as my center expertise.
Okay.
So I'll go as far as I can in responding to that question.
All right.
First of all, the vibrations of the strings in string theory,
Okay.
they are what is the manifestation of the universe we know.
Okay.
You vibrate them one way, you get an electron.
Right.
You vibrate them another way, you get a particular species of quark.
Okay.
You vibrate them another way, you get a... So all of these vibrations come together in this symphony we call our universe.
Nice.
What I do not know is whether the vibrations of the strings are also implicated in the laws of physics themselves.
Okay.
I just don't know.
Right.
Yeah, we had to bring somebody in for that.
Yes.
But if they are... I think it's a brilliant premise. He said he's writing a book. I assume it's a science fiction book.
It would have to be.
Yeah, it would have to be.
I'm just saying. I mean, no disrespect to Greg, but
No, it's a great.
have to be
I think it's a great and fertile idea.
Right.
That what you might do is you go into some vibration room.
Right.
Let's say, okay, and it would have control over the vibrations of your strings.
Right.
In such a way that you would create a different symphony of vibrations that are the vibrations of another universe.
Nice.
And because in the multiverse, other universes have slightly different laws of physics. We expect that to happen. Quantum physics clues us into how and why that should be the case.
Right.
So if you needed a way to sort of get somewhere, maybe, give yourself a new vibration.
A good vibration. What? I was about to say, good. All right. Yo, that's great. Hey, Greg, great.
Are you mixing two songs there?
No.
You were mixing...
Good vibrations.
Oh, so that's Rolling Stones.
No. That was
Marky Mark.
Beach Boys.
Oh, but then Marky Mark.
You're talking to Marky. Come on.
That's what I'm saying.
Feel the vibration.
Oh yeah.
Come on.
Good vibration. Isn't that called good vibration?
Yes, you're right. It is. Right. I totally forgot about that.
That's what I'm saying.
Oh yeah.
Were those other songs called Good Vibrations? Or
I think the Beach Boys was Good Vibrations as well. Good vibrations.
Okay.
Yeah, I'm pretty sure.
More than one song in the universe.
Yeah, there you go. Look
Good vibrations.
So
it'd be cool if your transporter room would be a place where they differently vibrated.
Flip the strings in different ways.
Strings in different ways.
Wow.
Yeah, so take it and run with it.
Yeah, go ahead, man.
Invite us to the premiere of the movie.
Yeah, good luck with the book. And
right.
Yeah, we want to be at the premiere of the movie.
Yeah.
Yo, super cool. All right, let's move on to Dawn of the Dave from Instagram. Just gives us that. He doesn't give us where he's from or anything like that.
It's from Instagram.
He's from Instagram.
All right. By the way, every Instagram post should have a photo, right? Was there a photo attached to this?
I'm sure there was, but we probably just took the text.
The text, okay.
Dawn of the Dave says, if scientists, and I'm going to change this to I'm going to personalize this, had access to 100% of the world's computing power, what would you like to focus on? So every possible data bit
Okay, so let's
is
go.
going to be pointed at this one
Exactly.
thing.
So
What would
let's-
you like it to be.
Let's go back to Archimedes,
Okay.
who said, upon understanding how levers work, give me a place to stand, and I can.
Watch from there. I don't know Archimedes.
You don't know this famous quote?
I don't know his famous quote. Give me a place to stand.
And I can watch TV. No, no.
Watch, because I like to watch.
Give me a place to stand, and I can move the world.
Ooh, I like that.
Yeah, that's perhaps his most famous quote.
I did not know that.
Yeah.
So give me a place to stand.
Okay.
And I could move the world.
Right. And so okay. And in the era of classical physics, it was imagined that if you knew, classical physics, 19th century classical physics.
Okay.
If you knew the position and momentum of every particle in the universe in this moment, you will know all future history of the universe that follows.
Wow. Okay, now I got to tell you, you lost me on that because just by knowing every position of every particle
in the universe.
Oh, because then you would know the movement of every particle from that point.
From that point.
And from that point, so you would be able to, okay, never mind. I'm getting excited because you can see the light bulb just went off. Okay, this is what happens when
Chuck just had a mental orgasm.
Yes, like I did, right. It was great. It was like Oprah climbed inside my head and was just like, you get it now. So go ahead.
All right. So because if you know that moment, then you'll know the next moment.
Right.
And then all the particles interact with one another.
Exactly.
And you get the next moment. So then there's nothing unknown for the future of the universe. Right. So
every single moment from that point forward is knowable
then be known.
Because you know exactly. Gotcha.
Correct.
Go ahead.
In principle, this is what was proposed. And this is not any different from, let's say you have a pool table, and the balls are all in motion in a given instant.
Right.
And then you can say, I will now predict for the future what balls will go in, what pocket, and what not.
Right. And then because at that point, if all the balls are in motion, it's a matter of simple geometry.
Correct. Well, physics. Yeah.
Physics.
Both.
Right.
And so the interesting thing about that is each ball affects another ball. In that case, not gravitationally, but I hit you. You could hit two other balls before you go in.
Right.
And so that was the idea.
Right.
So
and then you're taking into account transfer of energy, momentum, all these things, but you know them all, so it doesn't make a difference.
Exactly.
Right.
Exactly. So what I would do is try to compute you load up the position and momentum of every particle in the universe into this supercomputer, and then be able to predict all future movement of everything in the universe. Wow. Here's the problem that we learned in the 1920s.
Okay.
There's this little thing called quantum physics.
Right.
Where the universe in the quantum is not deterministic.
Right.
It is probabilistic.
Right. So it doesn't respond the way it would in the physical universe.
In the deterministic universe.
Right.
So it puts a random element to it that prevents you from knowing with certainty what tomorrow will be just for knowing about today.
Right.
Yeah.
Because even though the known is known, the unknown is always unknown. In the quantum.
And in the quantum. Ooh, very nice. And so, but nonetheless, I would go through that exercise.
Right.
And resurrect this old notion that so that would be the universe without quantum physics.
Sweet.
Yeah. So if I were to program a universe in my computer, that's the one I would program, and I would just check it out. The quantum-free universe. We're back. Star Talk, Cosmic Queries Edition. I'm Neil deGrasse Tyson, your personal astrophysicist, and Chuck Nice.
Hey, Neil.
Chuck, you're tweeting Chuck Nice Comic?
At Chuck Nice Comic. Thank you, sir. That is correct.
Dude, I like it. Anytime something happens in the world, I go to your Twitter stream and you're on top of it in some way or another.
I like to...
The politics, or somebody says something stupid.
I like getting a little dig in there now.
You're digging in.
I like to dig in there just a little bit.
Oh, yeah, so I follow you.
I follow you too. Well, of course.
And I don't follow many people, just so you know.
I know. And I find out I always know when you talk about me ever on Twitter because my Twitter goes crazy. Okay. And I'm just like, what the hell? What's going on? Oh, you mentioned, you said something like, Chuck's learning astrophysics every day. I might just turn the reins over to him. And I'm just like, no! Please don't say that!
I did say that. I forgot.
You said that on Twitter. I'm like, please! Do not say that! So,
all right, so what do you have?
Cosmic queries. Let's jump back into it. We got a bunch
Gumbo.
of Galactic Gumbo.
Give me a dose of dark matter in
That's right, put a little donut dark matter on that. Right, that's right. That's the little etouffee of the universe. This is Melissa Wolf from Facebook. And she is writing on her Facebook account from Chino Valley, Arizona.
All right.
Melissa says this. I'm very curious.
By the way, Arizona has two of the most famous holes in the world.
Okay. Not sure where this is going.
No. It's got the Grand Canyon.
Okay, that's
a hole in the ground.
I look at that more of a ditch than as a hole, but
okay, fine.
The
And it's got the Meteor Crater.
Oh, okay.
Yeah, also known as Barringer Crater.
And is that the crater, the mass extinction level event crater? Is that one, or is that?
That's what you would say if you were where that hit. That's correct. It's a crater. It would whatever you would do in there, you would gone.
Yeah, you did.
It's almost a mile wide, and it can sink a 60-story building from its bottom to the top.
Wow.
So it's the best preserved crater in the world.
All right. So now here's what I'm going to ask you. And
we haven't even got
Melissa,
to a question
I know
yet.
we're going to get to your question, Melissa.
Since I heard she's from Arizona, I got to put Arizona
but now that you
on the map.
Now that you brought up this crater, it's a mile wide, which, I mean, that's
nearly a mile wide.
Nearly a mile wide. I mean, so the impact just phenomenal, incredible. We know. However, now I got to ask you this.
By the way, it's just to be clear, it was not the one that took out the dinosaurs.
Right. I'm just saying.
This was small potatoes.
Right. This is right. That
compared to that.
That was the size of Manhattan or something.
No, size of Mount Everest.
Size of Mount Everest. That's what it is. So, God.
Yeah.
That is mind-boggling. Yeah. But so that crater, this meteor hit ground, right?
Yes.
Okay. Now here's what I want to know.
Yeah.
All right. What if it hit the ocean instead of the ground? That same impact.
Okay, so it turns out if an asteroid is big enough,
right,
it don't matter ground or it just doesn't matter. So,
doesn't matter.
So in the following way, suppose an asteroid is 10 miles across.
Okay.
Wow. Some are. That is larger than the depths of the oceans.
True.
So it'll just spread the water.
Yeah. It's like dropping a brick into a puddle.
Into a puddle, exactly.
It's like dropping a brick in a puddle.
Exactly.
It doesn't make a difference.
It doesn't make it. You're going to hit the ground,
right.
and you'll create great tsunamis. Yes,
yeah.
But that won't be your biggest problem.
Right, exactly. The tsunami will actually be refreshing compared to the aftermath that follows.
Exactly.
I got you.
The climate change and all that would unfold.
Okay, cool.
Yeah.
Cool.
So, but it is true. On the ground, it would make if a small enough one.
Right.
That one was the size of the sphere at the Rose Center for Earth and Space.
Okay, gotcha.
You can measure that up and figure that out.
Wow, and that's tiny compared.
It's tiny compared to Mount Everest.
Oh my God.
Oh yeah. It's a shooting gallery out there. So that one, if it hit the ocean, it probably would not have reached the bottom of the ocean.
Okay.
The ocean was really deep.
Right.
Like where the Titanic sank, it was like miles deep.
Right.
So, but all that energy would then get deposited into the oceans.
Right.
Then you get a tsunami that would come in very far inland.
Gotcha.
Yeah. Mm-hmm.
Okay, cool. All right, so Melissa.
It would have taken out the coastal cavemen. It would have disrupted the shipping lanes.
Oh dear, Trog, I do believe we're going to lose our
your beachfront
beachfront property.
Trog.
Lothar, my friend, do you have any property that isn't beachfront?
Oh, this was 50,000 years ago,
exactly.
So we was totally in caves back then.
Right. Oh my goodness, fellas, grab your women by the hair and let's get the hell out of here. We've lost our beachfront property. Okay, here we go.
We'll We'll get to her question in a minute.
We'll get to you, Melissa. We're getting to you, Melissa.
I got one. Wait. So
Go ahead.
I have to boast of something.
All right, go ahead.
One of my proudest moments writing was I wanted to come up with a female caveman name.
Right.
Because all the names we have are male.
Yeah, right.
No, Trog.
Trog, Lothar.
These are guy names.
Right,
okay.
exactly.
Can you think of a female caveman name? That's what I'm saying. It's
Wilma.
Wilma.
Does
Betty.
Betty count? Does Betty?
Betty and Wilma.
I don't know.
That's cheating. I
I'm
think.
cheating.
So here's what happened. The reason why I did this for one of my books, a Q&A book,
Okay.
on Merlin's Tour of the Universe. Someone had asked when the wheel was invented, and we have an idea of when, very early, but we don't know who.
Right.
So I wanted to invent a conversation that would have had between the people who might have invented it.
Okay.
So I want to be all PC about it. So I said it was invented by a man and a woman at the same time. But they're cave people, so I needed a name for each of them. So I said, what am I going to name them? I don't know. So then I remembered the word troglodyte.
Right.
And I said, and I'd forgotten what it meant. So I went to the dictionary and I looked up troglodyte, and it says cave dweller.
Right.
So, oh, okay. That's why that word popped into my head.
Right.
Deep down, I had some memory. But there's the dot that separates the syllables of the word in a dictionary.
Okay.
Troglodyte.
Lodite. Yo, and
There it was.
sounds like it sounds more female too.
So I said it was the Trog couple. I mean, it was the caveman couple, Trog and Lodite.
Trog and Lodite.
Invented the wheel.
Right.
There it was.
You know, Lodite was telling Trog he was doing everything wrong. You know it. You know, Lodite's just like, Trog, you know this is not how make wheel.
Is that how they smoke?
Right, exactly. And
Broken English.
Right, exactly. Because isn't that how whenever we don't know what people did, it's got to be broken English.
Broken English.
Just broken, you know. So yeah, and then and then Trog is just like, woman off my back. So wow, that's pretty cool. Lodite.
Yeah.
I like it.
Yeah, Lodite.
All right.
I'm very proud of that. It's my contribution to literature.
Trog and Lodite, the cave dwelling couple.
Yeah.
I like it. That's pretty cool. All right, Melissa, here we go. Melissa wants to know this, coming to us from Chino Valley, Arizona. Hey, Neil.
Finally getting to Melissa's question.
Finally.
Yes.
Hey, Neil, I'm curious about your thoughts on somewhat combining creationism with the Big Bang. Although I am agnostic, I was raised Catholic, and I always wonder why no one seems to consider that a possible higher power is behind the Big Bang and consequently dark matter. So do you have any thoughts on that? I mean, from a scientific standpoint, you cannot speak to this because you're speaking about, you know, the fact of a creator or some higher power creating this.
Oh, sure you can. If
you
science,
can.
Well, so let me be clear.
Okay.
This, if there's a higher power that did anything in the universe, there's no reason why that should be beyond the ability of science to determine that.
Oh, okay.
All right?
Interesting.
So if you do science properly, you're not precluding any one explanation relative to another if you're on the frontier of discovery.
Right.
Okay? So I'm not going to say there is no higher power there, and let me find something else. If the higher power is there and it manifests, then my methods and tools find it, I'll be the first one to report it. Okay?
Right.
I'll be up right there at the front of the press conference. Okay?
Right.
So just to make that clear. And let's back up. This is a deep question here.
It is.
It's got more going on than she may even know.
Okay.
After Einstein advanced the general theory of relativity in 1916, it was, oh my gosh, the universe, there's gravity and it shapes the universe in this way. And then in 1929, Hubble discovers that the universe is expanding.
Right.
You take general relativity and the data that the universe is expanding, and a clever physicist named Georges Lemaitre, he was a Belgian physicist, looked at that and he said, wait a minute. If we're expanding and I have this new tool, theoretical tool to understand the whole universe, let's go back in time and ask, what would the universe have been yesterday compared with today?
Right.
It would have been smaller.
Right.
Let's go even smaller.
Even smaller.
Take it all the way back.
So we go all the way back. We got to get down to a singular point.
A singular point.
Right.
A beginning of things.
Right.
This person is a Belgian priest.
Oh.
An ordained priest.
He must have drank some good beer.
Oh, Belgian beer? Mm-hmm. I don't know that there's beer in the church. I think it's all wine, okay? It's the body and blood of Jesus, not the body and beer of Jesus. The ritual. That's right.
If it was the body and beer of Jesus, I'd have been hanging out. Here's to you, Padre. But go ahead.
So people immediately said, oh my gosh, you have found proof of biblical creation.
Oh, really?
They said this to him. And he, a Belgian priest, came all back in their face and said, no.
What?
Because the Bible says the universe was created in 6 days. The Bible says Earth was created before the sun. There's a lot going on in Genesis that is scientifically untenable.
Right.
But now you want to take just a little bit that said God created it and say, oh, therefore it proves the Bible when nothing else that follows it has any anchoring in observational science.
Right.
He was smart enough to know that this, when I say smart enough, he was sensible enough to know that this should not be invoked as evidence for God creating Genesis as described in the Jewish Bible, in the Old Testament.
Old Testament.
So, because nothing else works there.
Right.
Okay? Nothing.
Right.
Okay, Earth is in the middle of things. Everything revolves around the Earth. Earth is flat. So this goes on and on and on. So he knew enough about the Bible and about science to not make that connection.
Gotcha.
Okay. So now, by the way, higher power could be God, or it could be some intelligent alien in its basement programming our universe for its own entertainment. That would be a higher power.
Wow.
If you think about it.
Yes, that would be a higher power.
Yes.
That guy's really effed up, man.
Especially
if that's the guy, hey, dude, if you're in your basement right now,
your parents' basement, it's the alien version,
you little pimply face alien bitch, this is effed up what you just did.
Then I wonder if we are a simulation, programmed by a higher power. Maybe they get bored every now and then, and they throw something to just throw in something in the mix.
A little glitch in the matrix.
Little glitch in the matrix.
Right.
You know, they throw down a disruptive politician or world war.
Right.
Or
that would explain so much.
Right? What? Completely explain it.
Oh, God.
Everything's going along just fine and tranquil, and they say, nope, you're not entertaining me anymore.
Lodite, watch this. Look at what I do right here. You know? Dog, how many times have I told you to stop screwing with those people?
But a broader reference to that question is, we don't know what happened before the Big Bang, and we also don't know what dark matter is, nor dark energy.
Right.
If you, and I've said this before, and listen to my words very carefully, if your understanding of God flows through places where science has yet to tread, because these are frontiers, before the Big Bang, if that's your concept of God, then the history of this exercise shows us that God would then be an ever-receding pocket of scientific ignorance.
Well, of course. I mean, that only makes sense because you're saying all these other things are provable and knowable. And so we know
these other things at one time in the past
they were not
mysterious.
They were mysterious. So now that we know these are provable and knowable and why they happen, these phenomena are actually explainable, right? Then
what's your plural phenomenon? Your plural phenomenon, phenomena. Very good.
Do you like that I actually corrected myself there?
Very good.
Yes,
I'm checking you out here.
That's cool. So and then you say, well, But what I don't know here, I just think that this is God doing this. But then our knowledge, our bubble, our knowledge expands.
Right.
It encompasses that event. That event is no longer now attributed to God. That event is also now provable and knowable. And then that now cannot be
So
talked
philosophers call this the God of the gaps.
What's it called?
Philosophers call it the God of the gaps.
God of the gaps.
Right.
So in other words, wherever your understanding fails you, you fill it in with God.
Fill it in with God.
Okay.
And by the way, this is a long tradition to do so. Okay. Isaac Newton did it.
Oh, really?
Isaac Newton wrote down his equation of gravity, and it described Earth and the moon,
right,
and the sun and the Earth,
right,
and Jupiter and its moons. We would later learn it. So this is all. So, but how do you then describe the whole solar system all happening all at once?
Right.
Everything tugging on everybody in all directions at all different. And he tried to calculate this,
right,
and the solar system was unstable, and planets would fly apart.
Right.
Because every time you came around the backstretch, Mars would tug on you a little bit.
Right.
Come around the next time, Mars would tug on you a little more.
Before you know it, you're out.
You're out.
You're out the door.
Yeah, we out.
Right.
Okay.
You in the Kuiper Belt going, it's cold. Man.
That's right. So you would
God, it's
say,
cold.
So, so he said, well, clearly I know my equations work.
Right.
With the one-on-one situation. With the whole system, maybe God steps in every now and then just to fix it.
And corrects things.
Yeah, and corrects things.
Right.
He says this.
Right.
In his 18th in his 17th century lingo.
Okay.
He says just that.
Okay.
And so that's basically God of the gaps.
Gotcha.
Ptolemy, who put forth the geocentric universe.
Okay.
This is 2,000 years ago, has a little bit of God of the gaps in him. He looked up. People still didn't understand the planets going forward and then retrograde,
right,
going back. And he says, when I trace at my pleasure the windings to and fro of the heavenly bodies, I no longer touch earth with my feet. I stand in the presence of Zeus himself and take my fill of ambrosia.
Wow. Yeah, he did it poetically.
That's a God of the gaps argument. He doesn't understand it. Zeus is
his God.
Is hanging with him right there.
That's how I explain this.
That's how I got it.
That's super cool. See, my God of the Gap is 40% off, and it's not Labor Day. Okay. Thank you, God. This hoodie is awesome. Okay.
We're back on Star Talk, Cosmic Queries edition, specially topicked
Galactic Gumbo.
I love me some gumbo.
Oh.
It's like 20 ingredients in gumbo, something like that.
If it's done right, yeah. So Galactic Gumbo, let's get into it. Here we go. Mm-hmm. This is Kelly Dean from Facebook, and Kelly says this: space has been expanding since the Big Bang. When we see a galaxy 5 billion light years away, would that galaxy not have been closer 5 billion years ago and thus taken less light time to reach us in the first place? Signed, the Kelly Paradox.
Is that her handle?
That's her handle, the Kelly Paradox.
I like that. I've always loved the word paradox.
It's a good word.
Because it's got rhythm and soul.
It almost sounds like what it is.
Exactly.
That's what's cool about it.
Paradox. That would be onomatopoetic.
That would be onomatopoetic, yes.
Yeah. Paradox. Paradox. Well, you say that and just drift off into ignorance.
Exactly.
Paradox.
Paradox.
Yeah. So let me recast her question to mean exactly the same thing, but give it a little more science anchor to it.
Okay.
We see that galaxy 5 billion light years away, where it was when the size of the universe was such that it would take its light 5 billion years to reach us.
Gotcha.
Okay?
Okay, now that makes sense.
Right now...
Because it's still expanding.
Yes.
But
it has been expanding since the 5 billion years.
There you go. Therein is the rub.
There's the rub.
That's the rub.
So so we're about 14 billion years old, so 14 minus 5, carry the 2. 9 You always got to carry the 2. Right, in any arithmetic, you carry the 2. So it means the universe has been expanding for 9 billion years since it emitted the light to reach us.
Right.
So it is much farther away from us now in this instant than it was at the time it sent us that light.
Correct.
So when we speak of, I and my colleagues, we're a little bit sloppy. We're precise but sloppy. You ask, how big is the universe? I say 13 billion light years across.
Right.
Okay? Well, right at this moment, it's much larger than that. It's 4 or 5 times larger than that because it's grown since then. Okay?
Right.
All right.
Because we're measuring the light that we see at that time.
At that time. And so you have to put it in the model, figure out how much farther it would have gone, and that gives you the number. So when I just say to you it's 13 billion years, these are observable quantities. They don't come out of a model that you would project into the present for the things that are far away.
Right.
But the way I like thinking about it is 5 billion light years, that's very far away. Let's get one a little closer, 65 million. That's like really close.
Very close.
Compared to the 65 million light years away. So that galaxy, if they looked at us, what do they see?
So 65 million. Wait, we're 4.5 billion. 65.
No, it just.
I'm trying to.
What was going on Earth?
Oh, they're seeing us in our what's the name of that age? But they're seeing us getting wiped out.
Yes.
Let me just instead of trying to be all sciencey, I forget the name of the actual age. But what they're seeing is us getting wiped out.
The wiped outicus.
The wiped outicus, right? So what they're doing is they're looking through their telescope and they're going, "Oh, damn!
Hey,
Damn! Look what just happened!
Look what just happened." So they're seeing the asteroid hit Earth and render 70% of the world's species extinct. It's just arriving there now.
Right. Okay.
And meanwhile, we are 65 million years in the future of that information.
Exactly.
In a larger universe and in that future. So it's a fun way to think about it. If you had super duper telescopes, you see the past of other places.
Super cool.
Yeah.
Oh, well, hey, look at that, Kelly Dean. Great question, Kelly. The paradox.
The paradox.
Paradox.
No, the paradox.
Paradox.
Right? Paradox. Yeah. Well, there's a wine called Paradox.
I did not know that.
Except they spell it differently.
Well,
it's Pair.
Oh.
OF.
Right.
DUCKS.
Paradox.
Paradox. And it's like 2 ducks on the label. It's very good.
Paradox.
Paradox.
That's pretty cool.
It's a California wine.
All right. So here we go.
They're not a sponsor of the show, just to be clear.
Exactly. We're coming for it. We're coming for you, Paradox. All right. This is Tom Hyde from Facebook. Tom says, I've always wondered how the universe expanded faster than the speed of light. Faster than the speed of light. During the Big Bang, when the universe is full of matter and matter can't move faster than the speed of light. Please explain this to me as if I was 4. Because I am 4. No, I put that last part there.
No. So wait. If they, because I am 4.
Right.
If you're asking that question at age 4, then I'm answering you for it's a college. I will not be giving you a baby talk answer.
That's right. If you're 4 years old and ask that. But he says, please explain it to me as if I was 4. And this is somewhat related to Kelly's last question, just a little bit, when you talk about the expansion of the universe. And how
so if you go in the early universe, the expansion rate was more rapid than it is today. The expansion rate, for the moment, is slowing down, but it's going to speed up again later because of the influence of dark energy. Dark energy, yeah. But that's a separate phenomenon going on. So in the early universe, you were absolutely right. We expanded faster than light. But that does not violate the you can't move faster than light rule. I know that sounds paradoxical.
It does.
Paradox. So here's what's going on. The speed of light limit comes about from Einstein's special theory of relativity, which describes the movement of objects through the fabric of space and time.
Exactly.
Whereas general relativity describes the stretching of your fabric of space and time, not specifically things moving through it.
Right.
So the early universe, it is the fabric of the universe that's stretching.
Itself.
Itself.
So it's not something traveling through that. So it's the rubber sheet model.
Correct.
Where you have just a sheet.
And all the galaxies are embedded in that, and the sheet is expanding.
The sheet is moving.
But you are not moving information through space faster than the speed of light.
Right.
But if you're expanding the fabric, you can expand an unlimited speed relative to the speed of light.
So it really is like a rubber band. If you and I were pulling a rubber band right now, we could pull it slowly. We could pull it as fast as we want.
Really fast.
It doesn't make a difference.
Right.
But if we have something sitting on that rubber band.
In the rubber band, it's stuck in however it's the ant moving in the rubber band, it's limited.
Exactly.
That's right.
So cool.
And Chuck, we have a bell.
Ooh.
Lightning round. Okay.
Lightning round.
These are where I answer questions basically with sound bites.
There you
I
go.
always fail, but let's try.
Who cares?
Okay?
It's always fun.
See how many we can fit into the last 3 minutes of the show.
All right.
Okay, ready, go.
Matthew Coles from Facebook wants to know this. Big Bang causes outward expansion. Do we know which direction the origin or center is?
Yes.
We do.
It is in every direction. Okay, next.
Ooh, that was great.
Yeah, no. So it expands in every direction, and we are part of that expansion. So you cannot look back to any direction in space and say that's where the Big Bang happened. Any more than you could be on the surface of an expanding balloon and point along that surface and say, there's the center of the expansion.
Right.
Because the center of the expansion is backwards in time at a point where the whole balloon was in that one spot in the same place at the same time. Next.
Thomas J. Kastner from Twitter says, why do so many people imagine alien life as little green men? What or who created this strange image of aliens?
Oh, yeah, because the little green men with feet and torso and arms and head, because you have to pay an actor to wear that costume. And before CGI, every animate thing was either stop motion capture or had an actor in it. I think if we were not so limited in the early creativity, especially of the B-movie sci-fi from the 50s, maybe they would have been earlier in the more creative kind of alien.
Yeah.
But and that was the joy of seeing the movie Alien. Where that creature wasn't so traditional.
It wasn't a little green man.
It wasn't a little green man, nor was the Blob in the 1958 Steve McQueen classic, The Blob.
Which, by the way, very inventive.
Very inventive.
Very inventive.
It was an invertebrate alien.
Exactly.
What was it? It was a blob. That was it. All right, next, go.
All right, Pepsi Rules wants to know this. How many licks does it take to get to the center of a Tootsie Pop, Neil?
Well, when I was a kid, I tried all these things that I was just geeky enough. Wait. No. First, how old is this person? Because this is not even an ad anymore. How many licks does it take to get? So I realized that it completely depended on how wet your tongue was.
That's fun.
Because if your tongue were dry, it would take essentially forever.
Right.
So there is no one answer to that question. And I learned this as like a 12-year-old kid. And I said,
sugary research.
Not all questions have unique answers. Some of them have multiple answers, and get over that fact.
Oh,
okay.
Cool.
Yes.
Nice.
It could be thousands. It could be
three.
If you like dog slobber on it. Okay. We get two more in this.
Here we go. This is Tack Neely who wants to know this. We call the area between planets and solar system space. So what should we call the area between universes?
Ooh.
Nice question, Tack.
Great question. So if empty space is where you find nothing. By the way, we would later learn that it's a seething cauldron of what we call virtual particles. We learned this from quantum physics.
Right.
That's another show. But let's, for the moment, call it empty.
Right.
Where you find nothing. Well, if nothing is where you find the space between things, no thing.
Right.
Nothing. Do you get that? You got it? That's good.
I'm with you.
Can you hang?
I'm right with you.
Where there is no thing, there is nothing. Okay, fine. But if there's not even nothing,
right,
then you are in a higher dimensional place, and our vocabulary cannot really accommodate that beyond just saying it is the absence of nothing, where you might then call it Nothing, nothing.
So the answer, Tack, is Detroit.
What you We'll be back to Star Talk Cosmic Queries in a moment. Back on Star Talk. Chuck,
Hey, Neil.
bringing me the questions.
That's right.
This is office hours.
Office hours. So
It means it could come from anywhere.
anywhere, anything.
Anything.
Let's jump into anywhere and anything. Here's Wolf Prime 06 from Instagram.
Okay, you notice people have been spelling their names phonetically for you.
And I appreciate that. And let me tell you, I don't have a problem with it. I'll take the help wherever I can get it, okay? I am not proud.
All right.
All right, Wolf Prime 06 Instagram says, cloning exact particles and cells might be the only chance we have at teleportation. So if we thought it was unethical, then would we stop cloning and therefore never figure out teleportation? So there's an assumption there that cloning cells is the way to teleport.
Interesting. Okay, so a couple of things. As far as we know, every atom of a particular kind is identical to every other atom of a particular kind.
Mm-hmm.
So you don't actually have to move your atoms to another location. Just get the recipe,
Right.
right? All right, so grandma's cupcakes, she doesn't make cupcakes for everyone in the universe to have her cup. She makes the recipe.
Okay.
Writes down the recipe. Now you reproduce her cupcakes.
Right.
Okay. So if I know exactly how all of the atoms of your body are configured, and I know what those atoms are, in principle, I can reconstruct you. What we don't understand yet well enough is the mind. And what is it about your mind that you would have to reconstruct to have the memories that you have, the life that you have, that can have your identity?
Right.
Because, by the way, in society, we do have clones. We already have clones. But we shouldn't have clones, it'll be ethical. We have clones already. They're called twins.
Twins, right.
Okay? Twins. Are we taking one twin away and harvesting their organs for the other twin? No. We're pretty sensible about things.
Well, that's what I did with my twin.
That's what you were.
Just saying. All right. I drink a lot. I know this liver ain't going to
Did the liver.
liver and kidneys.
So,
Nice too.
well, because it's a clone of yours, it means it's drinking too.
There you go. You useless clone.
So I don't know that the ethics of cloning will ultimately become all that people fear it to be.
Right.
I just don't see that based on the knowledge of already having clones today. There's a danger that if you start cloning pre-existing life, then you will lose the biodiversity that assures the survival of the species.
Wow. Okay, so that's a great episode of Star Trek, by the way, where they go to a planet and the whole planet is made of clones. What happens, though, is through the replication, they start to see a degradation over a long period of time. And so this degradation...
They're not perfect clones then.
Not perfect clones anymore. And they're like, oh, my God, we're now having clones that are not what they should be. As a result, we have to reintroduce good old-fashioned horizontal mambo to get some biodiversity.
Oh.
And that becomes like the whole issue of...
Horizontal mambo.
Yeah.
Wow.
Yeah, so the people...
That's a thing.
Yeah, that's
Even in Star Trek?
I think I
It's
might...
an ancient Earth term
for procreation. Horizontal mambo. Dang, dang, dang. But the people are repulsed by the idea of...
because the cloning is so pure and so high,
Yeah.
high level.
Right.
Interesting.
Yeah,
I missed that episode.
It's a pretty cool thing.
It's not from the original Star Trek.
No, I believe this is during. I think this is one of the Next Generation episodes.
Next Gen, yeah.
It's a Next Gen episode.
Yeah. So there's the ethics. There's whether it'll happen, and I think ideally you would just know exactly what the recipe is for an individual created in another place. Here's the thing you got to remember: twins are identical to one another, but they have different consciousness.
Right.
So one twin is not thinking it is the other, even though all the molecules are identical. So, except they have different fingerprints because that happened later in the womb.
Okay.
But so that's an interesting fact. Twins are identical except for their
Except their fingerprints.
Right. So So we're talking about identical twins, of course, not
not fraternal, where it's
or sororal twins.
sororal.
Yeah,
Wow.
like that one from Bill Nye.
Okay.
The two ladies in the womb.
Exactly.
Are sororal twins, and so we don't understand why I wake up as me and you wake up as you every day.
Right.
We just don't understand that.
Right.
And if we did, maybe we'd be able to clone that. But then you'd have two of you, and you'd have a simultaneous shared conscious. That'd be kind of interesting.
That
if you
would
could do that.
Yeah, I don't think we need two of me with a simultaneous shared consciousness. That is for sure. Oh, that's very cool then. All right, let's move on to...
two of me. One of me would be like in the lab, the other be doing the dishes, and the other be seeing the movie I've been missing. And you merge the conscious overnight. Wouldn't that be cool if you go to sleep?
All of you you go to sleep and you all share your experiences.
Yeah, it's a syncing program that synchronizes up the consciousnesses.
Now that I could deal with. That'd be kind of cool because then you could experience so much more in life.
There was a science fiction movie where people shared dreams. And I forgot which one that was. I forgot the name.
Not Inception. No, that was where you went into the dream.
Yeah, it went
deeper and deeper
into somebody else's
right, and that became the reality.
There was one where it might have been an episode of a TV series, but we'll get our crack team of researchers to dig it up.
There you go. All right, here's Lamis Pisu, I think.
That cannot possibly be.
I think it's Lamis Pisu.
Lamis pea soup. Okay.
Not Pisu. From Instagram says this, very, very succinct question. Where is all the antimatter? Wow, hey.
I wish I knew. Next question. Actually, there's a friend and colleague of mine, J. Richard Gott III, who wrote a research paper in the 1970s hypothesizing where all the antimatter went.
Interesting.
Yeah.
I did not read that paper.
You missed that?
I missed that paper, oddly enough.
Oh my God.
And what was his hypothesis?
He suggested that at the point that we had this asymmetry between matter and antimatter in our early universe, that there was I'm paraphrasing some of what he said because the details are a little fuzzy because it was 40 years ago. But at some point, all of the antimatter funneled out of this universe and created another universe with an antimatter-matter imbalance that's the inverse of our matter-antimatter imbalance.
Oh, man.
It's beautiful.
Great.
It's a really beautiful
thing.
Very
elegant.
It's elegant. He thinks up elegant things, whether or not they're true.
Right.
They're elegant.
Yeah.
And the universe just... There's a great comment, I think it was it Aldous Huxley? The Great Tragedy of Science, a beautiful theory slain by an ugly fact.
I love that.
So it's a elegant concept that there's still balance in the metaverse,
right?
And because this imbalance is kind of it's disturbing,
yeah,
in the greater scheme of things. So, but there's no evidence for this other universe. So
okay,
that's why.
all right.
Yeah.
All right, J. Lawrence74 from Instagram says this. I believe in an earlier episode, Neil said that the shape of the universe is a saddle shape. Is that right? If not, please, what shape is it? I can't imagine it not being a sphere.
Yeah, so we're flat. If I said saddle, so there are different shapes it can be.
Okay.
Still be consistent with Einstein's equations. And so one of them is sort of spherical, another is sort of flat, and one is saddle shaped. So one is positively curved, one is zero curvature, one is negative curvature. And so if you add up the dark energy and the dark matter and the matter and the energy, add it all up, the universe is flat.
Wow.
Yeah.
So there you have it.
Yeah. So it's interesting. So if one of them had a greater value than the other, then we would have one of these other shapes. And what's the difference? In a spherical universe, parallel lines always meet. In a flat universe, which is, we learned about flatness in geometry class, parallel lines, they meet at infinity, I think was the phrase, but basically they never meet.
They never meet, right.
And in a negatively curved universe, parallel lines diverge.
Right.
So these are three completely legitimate geometries. And so Euclid was a flat universe, and the others that are not Euclid, you know what we call that?
No.
Non-Euclidean geometry. I hate calling something in reference to what it's not.
Yeah, that's a little disappointing.
Right.
You know what I mean?
I wanted Freddie's universes, Freddie came up with it.
Right.
No, but I don't like unretouched.
Unretouched.
Yeah, that meant you didn't do anything to it.
Right, exactly.
Shouldn't have to have a word.
It shouldn't have a word.
Yeah.
It's just what it is.
Non-fiction. I want to invent a new one called faction. I'm going to do that. I'm going to send out a tweet.
Factions.
I write non-fiction,
right.
but I don't want my stuff referencing what somebody else did.
Right.
So, I ain't doing that. I don't play that.
Sweet. Okay. I think we have time for one more
question.
Okay, one more. And here's this is SEBSP at Instagram. Says this: could the gas giants still be forming planets, or a planet in formation, I think is what they mean.
I think you're right.
Because otherwise it doesn't make any sense, because Jupiter is a gas giant.
It's a gas giant, and it's not a star.
So, right. So I guess they mean a planet in formation.
So Jupiter radiates more energy than it receives from the sun.
Oh.
So you want to call it a star under those? It gives off more energy than it receives from the universe.
Yeah.
But generally we define stars as having a source of thermonuclear fusion in their core.
Okay.
You can emit energy if you're slowly collapsing.
Mm-hmm.
That you get hotter if you do that, if you're just slowly collapsing. Or if heavier things are dropping to the center as lighter things rise to the surface. These phenomena, it turns out, you will heat from this.
Right.
It turns out. But gas clouds that make gaseous planets, out of the starting box whether they're going to be stars. This is not something that happened. Gee,
That's it. Right.
I want to be a boy one day. I don't need my strings attached.
Right.
No, the mass is either going to take you there or it is not.
Gotcha.
And there is the Netherland, which is what we call brown dwarfs, which are transitional. We say transitional, but we don't mean it in the way you might think.
Mm-hmm.
You have massive planets like Jupiter. You have low-mass stars, and you have this thing in the middle that we call brown dwarfs.
Right.
They're not transitional in that they're not evolving from one to another.
Right.
They just occupy this middle zone between what a planet is and what a star is. And they're failed stars. They're overachieving planets, failed stars, whatever you want to call them. But we have a term for them. They're called brown dwarfs.
Brown dwarfs.
Yeah.
Sweet. All right.
You got it. Chuck, thanks for doing this.
Always a pleasure.
Always there.
Hey, listen.
You're always there for me.
Where else do I have to be?
Well, you don't got gigs?
I just do them on the side.
On the side. Oh, okay. We are your main squeeze.
Yeah, that's it. You know what I mean? I got my little side pieces.
All right.
You know what I mean? But every time they come calling, I'm like, now you know who my woman is.